Bismillahirrahmanirrahim. Our today's lecture is L'Hopital's rule for 0 by 0 form. This method enables us to find out limits when we have indeterminate form in our results. That is 0 by 0 form after putting the limits. In such cases, we take the differential of both numerator and denominator individually. This is not same as f of x divided by g of x. Apply the limits to check the result. If it is again indeterminate, then repeat the above procedure and keep on differentiating as long as the required result is obtained. The given example will make it clear. Now example. Limit x approaches to 3, x square minus 9 divided by x minus 3. Now first of all, we will check for the existence of the limit, that is, we are going to put the values of the limit x approaches to 3 and we have x square minus 9 and whole divided by limit x approaches to 3 x minus 3, just in a normal way to evaluate the limit. Now when we apply the limit here, we get 3 square minus 9 and 3 minus 3. So 9 minus 9 divided by 3 minus 3, which is, we cancel 9, 9, 3, 3, we get 0 by 0 form. Now, here we are going to apply the L'Hopital rule. Now apply the L'Hopital rule. That is, we will take the differential of the numerator and the differential of denominator individually. Limit x approaches to 3 d by dx x square minus 9 whole divided by d by dx and x minus 3. So limit x approaches to 3, we have 2x minus 0 whole divided by 1 minus 0. Therefore limit x approaches to 3, 2x, here we can so to limit x approaches to 3 x, we get 2, 3 and 6. This is our answer. Now let's start questions. Again, in this we have to check the existence of the limit, which means we are going to put the value of x in the given function. So we have sine 0, applying the limit to 0. Now the value of sine 0 is 0 and divided by 0. So we have indeterminate form. Now apply L'Hopital rule. So differentiating numerator and denominator separately. limit x applies to 0, so d by dx sin x over d by dx 2x. We have limit x approaches to 0 and the derivative of sin x is cos x whole divided by 2. Now apply the limit, we get cos 0 divided by limit x approaches to 0. So 2 is a constant, so limit will remain same, and the trigonometric value of cos 0 is 1 over divided by 2. This is our answer. Now question number 2, limit x approaches to 0 sin square x divided by 3x square. Again check for the existence of the limit. Limit x approaches to 0 sin square x whole divided by limit x approaches to 0 3x square, and again sin square 0 over 3 0 whole square. Now the trigonometric value of sin 0 is again 0, and 0 multiplied by any value is again 0, so 0 over 0, which is indeterminate form. So apply again L'Hopital rule here. Applying L'Hopital rule. So limit x approaches to 0 d by dx sin square x whole divided by limit x approaches to 0 d by dx 3x square. So limit x approaches to 0 and the derivative of sin square x is 2 sin x into cos x whole divided by limit x approaches to 0 6x. Now applying limit, we get 2 sin 0 cos 0 over 6 0. So the value of sin 0 is 0 and cos 0 is 1, but anything multiplied by 0 is 0 and 6 multiplied by 0 is 0. So again it is indeterminate form, and we are going to apply the L'Hopital rule again. Now since it is again 0 over 0 form, so we will apply L'Hopital rule again. Limit x approach to 0 to sin x cos x whole divided by limit x approaches to 0 and it is 6x. Here we can also use an identity, which is we have sine 2 theta is equal to 2 sine theta cos theta, which will be more simpler, as we get limit x approaches to 0 sine 2x whole divided by limit x approaches to 0, 6x. Taking the differential, d by dx sine 2x and limit x approaches to 0, d by dx 6x. Now we have the differential here, limit x approaches to 0, cos 2x, then the derivative of the angle, which is 2, and whole divided by limit x approaches to 0, and the derivative of 6x is 6. Now apply limit. We get 2 cos 2 is 0 and whole divided by 6. The trigonometric value of cos 0 is 1, so we have 6 and it is 1 over 3. Answer. Question number 3. Limit x approaches to 0, sine 6x over sine 8x. Now applying the limit, sine 6x whole divided by limit x approaches to 0, sine 8x. So sine 6 0 over sine 8 0. So we have further simplification for that, that is 0 and 0. Now sine 0 is again 0 and sine 0 is 0. So again we have indeterminate form, and hence applying L'Hopital rule. Now applying L'Hopital rule. So we have limit x approaches to 0, d by dx sine 6x over limit x approaches to 0, d by dx sine 8x. Now we have differential of sine 6x as, first of all, limit x approaches to 0. This is cos 6x and derivative of the angle, which is 6, divided by limit x approaches to 0 and cos 8x and derivative of the angle, which is again 8. So applying the limit, we get cos 6 0 into 6 whole divided by cos 8 0 into 8. So for the simplification, we have cos 0, this is 6 whole divided by cos 0 with 8, and we have cos 0 1 divided by 6, again 1 divided by 8. So we have 6 by 8, and on further simplification we have 3 by, again first of all applying the limit, we have limit theta approaches to 0 and it is 0 Now question number 4. Limit theta approaches to 0, theta squared divided by 1 minus cos theta. So first of all, we are going to apply the limit as a division rule. First of all, limit. Again, the variable has been changed from x to theta. Whole divided by limit theta approaches to 0, 1 minus cos theta. So on applying limit, we get 0 whole square over 1 minus cos 0, that is 0 over 1 minus 1, because the trigonometric value of cos 0 is 1, so 0 over 0, so it is again indeterminate form, and applying L'Hospital rule. Now applying L'Hospital rule, so it is limit theta approaches to 0, d by d theta, because we are differentiating with respect to theta here, and limit theta approaches to 0 and d by d theta 1 minus cos theta. So taking differential, limit will remain as it is because we are not applying the limit here. It is 2 theta whole divided by limit theta approaches to 0, and it is 0 minus sine theta. This becomes 2 limit theta approaches to 0 theta over limit theta approaches to 0 sine theta. Now applying limit, we get 2 0 over sine 0, again 0 over 0 4. Now we are going to take the differential for the function. Again, limit theta approaches to 0 to theta, and whole divided by limit theta approaches to 0, and this is sine theta. Again applying L'Hospital rule here, applying L'Hospital's rule again. So limit theta approaches to 0 to d theta by d theta, and divided by limit theta approaches to 0 d by d theta sine theta, and we have limit theta approaches to 0 to, because the derivative of theta is 1, and limit theta approaches to 0, and the derivative of sine theta is cos theta. Applying limit, we get 2 and cos 0. Trigonometric value of cos 0 is 1, therefore 2 over 1 and 2. Answer. Now question number 5. Limit t approaches to 0, t squared divided by 1 minus cos squared t. Now applying limit here first of all. Limit t approaches to 0, we have t square, and limit t approaches to 0 and 1 minus cos square t. So on applying limit, we have 0 whole divided by 1 minus cos square 0, that is 0 over 1 minus 1, and 0 over 0. Again it is indeterminate form, and now we are going to apply again L'Hopital rule. Apply L'Hopital's rule. L'Hopital's rule. So limit t approaches to 0, d by t square, because we are differentiating with respect to t. Here the variable is t. Limit t approaches to 0, d by dt, 1 minus cos square t. So limit t approaches to 0, 2t whole divided by limit t approaches to 0. This is 0 minus, and we have 2 cos t, and derivative of is minus sine t. So limit t approaches to 0, this is 2t whole divided by limit t approaches to 0, 2 sine t cos t, and again it will be 2 limit t approaches to 0 and t whole divided by 2 limit t approaches to 0. It is sine t and cos t. This 2 and this 2 is cancelled, and we have limit t approaches to 0, t whole divided by limit t approaches to 0, sine t cos t. On applying limit, we have 0 over sine 0, cos 0, 0 over 0 into 1, because trigonometric value of sine 0 is 0 and cos 0 is 1. So again we have 0 over 0 form. Now again apply L'Hopital rule for the function. So limit t approaches to 0, dt by dt, and limit t approaches to 0, d by dt is sine t cos t. So limit t approaches to 0 and derivative of t is 1, because we are differentiating with respect to t, and here limit t approaches to 0, but applying here product rule. So we have sine t d cos t over dt plus cos t and d over dt sine t. Now this is 1 because it's a constant, whole divided by limit t approaches to 0, sine t minus sine t plus cos t into cos t. So we have 1 over limit t approaches to 0 minus sine square t plus cos square t. So finally 1 over minus sine square 0 plus cos square 0, and we have 1 over 0 plus 1, hence 1. This is our answer. Now question number 6. Limit x approaches to 0, 1 minus cos 5x divided by cos 7x minus 1. Now first of all, applying limit, we get limit x approaches to 0, 1 minus cos 5x whole divided by limit x approaches to 0, and this is cos 7x minus 1, and on applying limit we get 1 minus 1 over 1 minus 1 is equal to 0 over 0, which is again indeterminate form. So applying L'Hopital rule, applying L'Hopital's rule, limit x approaches to 0 and d by dx 1 minus cos 5x whole divided by limit x approaches to 0 d by dx and cos 7x minus 1. So here we have limit x approaches to 0, derivative of 1 is 0, and minus sine 5x, and then the derivative of the angle, which is 5. Limit x approaches to 0, minus sine 7x, then the derivative of the angle, which is 7, and it is 0. So limit x approaches to 0, 5 sine 5x whole divided by limit x approaches to 0, 7 minus sine 7. Now first of all, we are going to take the constants, which are 5 and 7, along with the negative sign outside the limit. 5 limit x approaches to 0, sine 5x over minus 7 limit x approaches to 0, and here it was actually sine 7x. Now again, when we apply the limit here, it is 5 and sine 5 is 0 whole divided by 7, sine 7 0, and it will be again 0 over 0 form, because the trigonometric value of sine is 0. Now again, applying L'Hopital rule, we have minus 5 by 7 taken outside because these are the constants, therefore limit x approaches to 0 and d by dx sine 5x whole divided by limit x approaches to 0 and d by dx, which is sine 7x. So it will be minus 5 over 7 limit x approaches to 0, and it is cos 5x, then the derivative of the angle, which is 5, and limit x approaches to 0, cos 7x, and the derivative of the angle is 7. Applying limit, but first of all we'll take these constant 5/7 outside the limit, and on multiplication it will be 25/49. Now first of all we will write it like that: x approaches to 0, cos 5x, and whole divided by limit x approaches to 0 and cos 7x. Now we will apply the limit. First of all, this is minus 25/49, and on applying the limit, cos 5 0 and whole divided by cos 7 0, so it will be minus 25/49 into 1 over 1, because the trigonometric values of cos 0 is 1. Therefore, we have obtained the answer, that is minus 25/49. Now question number 7. Limit t approaches to 2, t cube plus 3t square minus 12t plus 4 divided by t cube minus 4t. Now first of all we will apply the limit. So limit t approaches to 2 plus 3t square minus 12t plus 4, that is we are going to apply the division rule. So limit t approaches to 2, t cube minus 4t. So this is 2 cube plus 3 2 square minus 12 2 plus 4 whole divided by 2 cube minus 4 2 gives us 8 plus 12 minus 24 plus 4 over 8 minus 8, and on simplification we get 0 over 0 form, which is again indeterminate form. So applying L'Hopital's rule, we have limit t approaches to 2 d by dt, because we are differentiating with respect to t, which t is the variable now, plus 3t square minus 12t plus 4, and limit t approaches to 2 d by dt, and we have t cube minus 4t. Now on differentiating we get limit t approaches to 2, we have 3t square plus 6t minus 12. This is the result after differentiation. Limit t approaches to 2 and 3t square minus 4. Now putting the limit here, we have 3 2 square plus 6 2 minus 12 whole divided by 3 2 square minus 4, and this is 12 plus 12 minus 12 over 12 minus 4 and this is after simplification we have 12 by 8 and it is 3 by 2. This is our answer. 2, that is we have divided by 4. This is the answer. Now question number 8. Limit t approaches to 1, t cube plus t square minus 5t plus 3 divided by t cube minus 3t plus 2. Now first of all we are going to apply the limit to see the existence of the limit. Therefore, on applying limit, we get 1 whole cube plus 1 square minus 5 1 plus 3 whole divided by 1 whole cube minus 3 1 plus 2. We have 1 plus 1 minus 5 plus 3 over 1 minus 3 plus 2. We have 5 minus 5 and minus 2 plus 2, and on cancelling we get 0 over 0, which is again indeterminate form. So applying L'Hopital rule, now applying L'Hopital's rule, we have limit t approaches to 1 d by dt, because we are differentiating with respect to t cube plus t square minus 5t plus 3 and whole divided by limit t approaches to 1 d by dt t cube minus 3t plus 2, and on differentiating limit t approaches to 1, we have 3t square plus 2t minus 5 and whole divided by limit t approaches to 1, 3t square minus 3. Now applying limit, we have 3 1 whole square plus 2 1 minus 5 and whole divided by 3 1 square minus 3, which is 3 plus 2 minus 5 whole divided by 3 minus 3. So again it is 0 by 0 form. So we are going to apply L'Hopital rule again. Now applying L'Hopital rule again, we have limit t approaches to 1 d by dt 3t square plus 3t minus 5 whole divided by limit t approaches to 1 d by dt 3t square minus 3. On differentiating we get limit, because we are not going to apply limits yet, approaches to 1 and we have 60 plus 3 whole divided by limit t approaches to 1 and we have 6t. Now applying the limit we get 6 1 plus 3 and 6 1, therefore 6 plus 3 over 6 is equal to 9 over 6. Hence on simplification we get 3 by 2. This is our answer. Now question number 9. Limit x approaches to 9, x minus 9 divided by under root x minus 3. So applying limit, we get limit x approaches to 9, x minus 9 whole divided by limit x approaches to 9 and under root x minus 3. We get 9 minus 9 over under root 9 minus 3 is equal to 0 over 3 minus 3, which is 0 by 0 form, again indeterminate form. So apply L'Hopital rule for this. Now apply L'Hopital's rule. Limit x approaches to 9 d by dx x minus 9 whole divided by limit x approaches to 9 d by dx, and we have under root x minus 3. On differentiating we get limit x approaches to 9 1 whole divided by limit x approaches to 9 and 1 by 2 x raised to power minus 1 by 2. So we have limit x approaches to 9 1 over limit x approaches to 9 1 over 2 under root x. On applying the limit we have 1 over 2 under root 9. This is 1 over 1, 2 multiplied by 3 gives us 1 over 1 divided by 6. Therefore the final answer is 6. Now I would like to make clear that we have a rule which is rule for the divisions which are converted to multiplication is A over B, C over D, and we have A divided by B multiplied by D by C. So we have applied this rule in obtaining the answer, which is 6. Now question number 10. Limit x approaches to 0 under root x plus 4 minus 2 divided by x. Applying limit, limit 0 plus 4 minus 2 whole divided by 0. So 2 minus 2 over 0 is 0 by 0 form, again indeterminate form. Therefore applying L'Hopital rule. Applying L'Hopital's rule. limit x approaches to 0 d by dx under root x plus 4 minus 2 and whole divided by limit x approaches to 0 d by dx x. On differentiating we get limit x approaches to 0 1 over 2 x plus 4 raised to power minus 1 by 2 and this is 0 whole divided by limit x approaches to 0 and 1. This is, now we have limit x approaches to 0 1 over 2 under root x plus 4 over 1 because the limit of constant is 1, so still we write limit x approaches to 0. Now applying the limit we get 1 over 2 under root 0 plus 4 and this is 1 over 2 multiplied by 2 because the square root of 4 is 2 and hence this is 1 by 4 answer. Now question number 11, limit x approaches to 1 natural logarithm x divided by x minus 1. Now applying the limit when x approaches to 1 we have natural log of 1 and 1 minus 1. Now natural log of 1 is 0 and hence 0 again it is indeterminate form, so applying L Hospital's rule we have limit x approaches to 1 d by dx natural log of x whole divided by limit x approaches to 1 and d by dx x minus 1. So on differentiating we get limit x approaches to 1 and the derivative of natural logarithm of x is 1 over x into 1 whole divided by limit x approaches to 1, this is 1, therefore limit x approaches to 1 over x, therefore after applying the limit we get 1 over 1 which is 1 answer. Now one thing that we have taken the derivative of natural logarithm as 1 over x because we have a formula here we can write as y is equal to natural logarithm of f of x where f of x is the function. So when we take the derivative that is y dash or dy by dx, this f of x will be written as 1 over f of x and then we take the derivative of the given function f of x. So applying this formula we have obtained this result. Now question number 12, limit x approaches to 0 e raised to power x minus 1 divided by sine x. So first of all, applying the limit, we get e raised to power 0 minus 1 and sine 0. We know exponential of 0 is 1 minus 1 and sine 0 is 0, so we obtain 0 over 0 form, again indeterminate form. Now applying L'Hopital rule, L'Hopital's rule. So limit x approaches to 0 d by dx e raised to power x minus 1 and limit x approaches to 0 d by dx sine x. Here limit x approaches to 0 e raised to power x, which is the differential of exponential x, minus 0 and whole divided by limit x approaches to 0 and cos x. Here we apply the limit e raised to power 0 whole divided by cos 0. Exponential of 0 is 1 divided by 1, hence answer is 1. Now question number 13, applying limit theta approaches to 0 tangent theta divided by theta. So tangent 0 over 0. Tangent 0 is 0 and theta is 0, hence again indeterminate form. So applying L'Hopital rule, L'Hopital's rule, limit theta approaches to 0 d by d theta, because we will differentiate with respect to theta and tangent theta, whole divided by limit theta approaches to 0 and d by d theta and differential of theta. Limit theta approaches to 0, this is secant square theta, whole divided by limit theta approaches to 0 and derivative of theta is 1. Now applying limit secant square 0 over 1, because 1 is constant and the limit of a constant function is always constant. Now secant square 0 is 1 over 1, so now question number 14, limit t approaches to 0 t into e raised to power t divided by 1 minus e raised to power t. Now applying the limit 0 e raised to power 0 over 1 minus e raised to power 0. So 0 into any value is 0 and 1 minus 1, because exponential raised to power 0 is 1, 0 over 0, it is indeterminate form. Now applying L'Hopital rule, applying L'Hopital rule, limit t approaches to 0 d by dt t e raised to power t and whole divided by limit t approaches to 0 d by dt and 1 minus e raised to power t. So in the numerator we are going to apply the product rule. Limit t approaches to 0, t is the first function, and d raised to power dt e t plus et and d by dt t, and here limit t approaches to 0, d of 1 divided by dt minus d e raised to power t and divided by dt. So we have limit t approaches to 0, t e raised to power t plus e raised to power t whole divided by limit t approaches to 0 and 0 minus e raised to power t. Now applying the limit we get 0 e raised to power 0 plus e raised to power 0 whole divided by minus e raised to power 0. So we get 1 over minus 1. Minus 1 is the answer. Now question number 16. Limit x approaches to pi sin x divided by x minus pi. Now applying limit, first of all applying limit sin pi whole divided by pi minus pi. Now sin pi is 0 and it is 0, so again indeterminate form. Applying L'Hopital rule, limit x approaches to pi d by dx sin x whole divided by limit x approaches to pi and d by dx x minus pi. Limit x approaches to pi and the derivative of sine is cos x whole divided by limit x approaches to pi dx over dx minus d pi by dx. Limit x approaches to pi, because we have to differentiate the denominator first. Limit, then we are going to apply the limit. Now derivative of x is 1 and pi is a constant, so its derivative is 0. Therefore limit x approaches to pi cos x, and if we see 1 is a constant and the limit of constant is always same, so it will be 1. Now apply limit cos 180 and cos 180 is 1. Answer.